What is going on, guys? Welcome back to the second episode of the R tutorial series. In this video today, we're going to learn about the basics of the R language like variables, operators, and data types. So let us get right into it. Alright, so we're going to get started with the coding in this episode today. The goal is to cover the very basics of the R programming language, and we're going to cover things like console output, creating variables, assigning values to them, doing some basic operations, math operations, text operations, logical operations, and we're also going to take a look at the different data types and how to convert them. Now, let us get started with the console output. How do we output things onto the command line, onto the console? Remember, we have our code or our file where we're going to write our code opened up here. We have our environment here. We're going to see all the variables and data sets and so on here. Visualizations later on will be displayed down here, as we said. And this here is the console, the command line where we're going to output, or where we're going to see the output of the code we run. So remember also, we can run individual lines of code by pressing Control Enter, or we can select an area of code and press Control Enter, or we can also click this button here to do the same thing. And the basic way, the easiest way to output a value to the console is to just provide a single value. For example, 10. And if I now run this line of code, I'm going to see 10 as an output in the command line. So you can see here I have 10 as input, 10 as output. Now, if I turn this into an expression, 10 plus 20, for example, the output is 30, because that's an expression, it's evaluated, the value of this expression is 30. Now, if I want to have not just a number, but for example, a text, if I want to show the text hello world in the command line, what I can do is I cannot do it just like this. If I try this, you can see it doesn't know about the symbol hello world. It's looking for a variable or a data set or a function or something. If I want to specify that this is just a text that I want to display or use, I can surround it with quotation marks. So I can just use quotation marks and I can then run this and you can see the output is hello world. And this also works if I have numbers in here. So even if I have something like 10 plus 20, if I put quotation marks around it, it is considered to be a text, or the data type in R is called character. In other languages also oftentimes called string. And this is how we output or how we define text. Now, this works fine if we're just running individual lines of code. However, later on, we're going to see certain structures like loops or functions, which are not relevant yet. But the important thing is that just specifying something will not always be enough to print it or to show it on the console. If you actually want to show something in the console in a loop or in a function in another context when running the full script, for example, what you need to do is you need to explicitly print it to the console. So you need to use the print function. So you type print and then parentheses, and inside of those parentheses you put whatever you want to output onto the console. Now here, if I do the same thing here, hello world, you're not going to really see a difference. The output is the same, but this is relevant if we're going to, or when we're going to have functions, because in functions, if you just provide a value or a variable, it's not going to be printed to the console. You have to explicitly call print. So just keep that in mind. We're going to maybe talk about this later on again, but that is how you output things onto the command line. Now, we don't have to work with explicit values all the time. So we can also create variables. A variable is a placeholder for a value. So for example, instead of saying 10 plus 20, what I can do is I can store the values 10 and 20 in variables, and then I can do the addition. How do I do that? Let's say I want to create a variable called a, and this variable a should have the value 10. Now I can do that either with an equals sign, so I can say a equals 10, this is possible, or I can do this with an arrow. So let's say b is 20, I can also do it with this arrow here. So by using an opening angle bracket followed by a hyphen, this also works as an assignment, and usually it's not done. I don't know anyone who does this in R, but you can also assign the other way around. So you can also say 40, for example, is equal to C, the other way around. Possible, valid, but I don't know anyone who does that, so I would stick with either the equal sign or with this arrow here. And these variables now contain the values. So a is now 10 and b is now 20. And if I just type a and run this line of code, you can see I get 10 as an output. And if I say a plus b, I get 30 as an output because it takes 10 plus 20 which is 30. And I can also clean the environment as we saw in the last video. This deletes all the variables, and now if I run this, it will tell me that it doesn't know what A or B is. There you go, not found, so we cannot do the calculation. I would have to run these again, or I have to select the whole area here and run it. Then of course it works. So this is the basic idea behind variables. We use them as placeholders, and we don't have to constantly define specific values. We can change variables. We can keep track of values using variables. So I can say, for example, A right now is 10, but then A might change by saying A is equal to A plus 1. So I increase A by 1. Now A is 11. And we can do many things with variables. So this is a very basic concept in every programming language. And variables specifically when it comes to statistics and mathematics are, of course, a very important thing. So what we can do now is we can do certain operations with numbers. Now let's get started with basic arithmetic operations. What can I do? I can add two numbers. I can say 10 plus 20, which we did a couple of times now. I can also subtract. I can say 10 minus 20. I can say 10 times 20. And I can say 10 divided by 20. So this would be a slash for division and an asterisk for multiplication. These are now the very basic operations. What I can also do is I can use exponentiation. I can say 10 to the power of 20, which is, yeah, pretty large number. As you can see, a 1 with 20 zeros. And we can also do a modulo operation. So what happens when I divide a number? Let's say I divide 10 by 3, for example. What I get is a floating point number, but if I want to have an integer, I would say 3 and the remainder is 1. In order to get this remainder in R, I can use the percentage operator twice. So for those of you who know other programming languages, you usually just use 1% symbol, but in R you use both, so or 2. You have to say 10% 3 to get the remainder of 1. So the modulo operation. And of course you can combine all of them here with parentheses. You can say A plus 10 in parentheses divided by B plus 2 times 8, whatever, and then you get some result based on this statement. So this is just now a basic calculator. Nothing too fancy yet, just basic calculations. What we can do, however, is we can also call certain functions. For example, I can say square root, SQRT for the square root of 16, for example, is 4. I can also do stuff like exp, which is e to the power of, in this case, e to the power of 16. So let's go with e to the power of 2, for example, which would give me that. If I say, of course, e to the power of 1, I get e. What else can we do? We can do the absolute value of a number. I can say abs of -9 will be 9. Abs of 9 is also 9. We can do things like ceiling and floor. So if I have a floating point number, I can say ceiling 10.27, for example. This will turn it into 11. Then we have also floor 10.27, which would turn it into 10. And I think we also have round. If I have 10.27, it should automatically round it correctly. If I have 5.7, it goes to 11. So this is also something that you can use here. And we also have operations or functions here that we can apply onto multiple values. So for example, I can say max, and I can provide the values 10, 40, 20, 50, 15 or something, and then I get 50 as a result because that's the largest value. If I do the same thing with min, I get the smallest value, which is 10. And yeah, that's like some basic stuff that we can do on a math level. Now, all the time here, we're working with different data types. And if you're confused by what a data type is, it's basically on a low level, it's relevant for the interpreter to know what it does with the RAM, how much RAM it allocates, and how it interprets the bytes in the area of memory. But for you as an R programmer, it's not really relevant. You just need to know what you're working with. And in R, we have a couple of different data types. We have the data type numeric, which is basically everything, like a floating point number. You could say every number that's a real number. So for example, something like 10.2 is a numeric, something like 10 is also a numeric, but you can also have specifically an integer. So you want to have an integer specifically, you do that by providing an L, and you can see what data type you're working with by using the class function. So you can say class, and you can pass a value, for example, 10.27, and this is numeric, as you can see. Now, if I say 10, it's also numeric. If I say 10L, it's an integer. If I put this now into quotation marks, you're going to see it has the data type character, because that's a text. And then we also have a Boolean, or I think it's called a logical in R, which is basically either true or false. So in R, we have the special values here, T or F, or also true in capital letters, or false in capital letters. And these are logicals. So these are binary values, either yes or no, either true or false. And they are oftentimes the result of certain operations like membership operations, or so checking if something is part of a collection, or checking if something is greater than something else, or if something is equal. A true or a false will give us the information if something is the case or not. And it then can be combined with some control structures that we're going to talk about later on in this tutorial series. But for now, just know we have these different data types, and we also have another one, I almost forgot this one, which is the complex. So we can also have complex numbers, 10 plus 8i, for example. This is a complex number. Yeah, so these are the data types, and they can also be converted. So we can take a float or a numeric, and we can turn it into a character. How do we do that? By using as. So as dot, and then we can just use the data type as character, and then I can pass here 10.27. This will turn this into the character, into the text 10.27. The other way around, if I have a text 10.27, I can also interpret this text as a numeric. And you can see now it's a number. So I can take this plus 10, and it will give me 20.27. If I take this plus 10, it will tell me that this is not possible because I'm trying to add a number to some text. This is not reasonable here. So this works, and if I provide something that is not a number, like some text here, it will also tell me that this doesn't work. It produces some invalid values because we don't have a number in here. So that's possible, and then there's also some conversion that happens if you take a number. So for example, as logical, you can pass the number 0, which is going to be false. As logical 1 is going to be true, and I think everything actually that is not 0 is going to be true. I'm not sure about negative numbers. Yeah, everything that's not 0 is basically considered true, and 0 is considered false. So these are the basic data types and how you can convert them. Now, let us talk about some things that we can do with characters, so with strings. Now, I'm going to probably refer to the text data type, which is called character in R, multiple times as string, just because it's basically in every other programming language called string. So don't be confused by that. If I say string, I mean the character data type, so text. What we can do with text is, let's say I have some text here, which I set equal to hello world. Now I have the value here. I can apply certain things, certain operations to it. For example, what I can do is I can get the number of characters. I can do that by calling the nchar or nCharacter function, and I pass text here, and I get 11 as a result. So I have 11 characters in here. What I can also do is I can concatenate strings and return them. This can be done with a paste function, so I can paste the string hello. By the way, you see I can also use single quotations. I don't have to use double quotations necessarily, but I can concatenate hello and world, and this is then combined into hello world. I can also assign this to a variable x here, and now the variable x has the value hello world. And what we can also do is we can output, we have a similar function called cat, which is also used for concatenation, but it doesn't return the value. So if I have hello and world, this does the same thing, but it prints it onto the console and it doesn't return something. So if I try to store this into x, x is null, so it doesn't have a value, but I still get the output. So this is like a print and paste combined, and this is paste and returns the value to whatever you want to do with it. Returning a value means I can then use it. So printing a value just means outputting it to the console. Returning a value means I can then take the value, so I can I can take this value and assign it to x. Here, we don't return anything. So if I try to return nothing, if I try to assign nothing, because this returns nothing, to x, I get null. So null is basically nothing. And this can also be useful for displaying stuff in a more human readable way. So for example, what I can do is I can say long text is equal to some text here, and I can say, for example, hello, this is a multi-line text. I can run this, and if I now try to just output this text, you can see I have these backspace n characters here. These are called escape characters. You don't need to understand this necessarily in detail, but basically a line break is represented in the form of a \n, and this is what is stored in the string. But if you call this with a cat function, for example, you're going to actually render this as an actual line break. So I can say cat long text, and then I'm going to see the line breaks properly. This does not happen if I use paste, and it also doesn't happen if I use print. So it only happens with cat. All right, and then finally, what I also want to show you is, or maybe one little thing also on the side, if you want to ever put some text into your code that is not part of the functionality. So you want to write something in here, but you don't want to actually do something. You just want to take some notes, for example. You cannot just go ahead and say, this is my note here to remind myself of something. This doesn't work because now it's considered to be text. Now you're going to probably get some error message here. There you go. And we can try to run this. It's going to say, okay, unexpected symbol, error. If you want to put some notes into your code, you can use a hashtag before that. So you can just say hashtag and then some note. This is called a comment, and you can do many of those. So you can put a comment wherever you want. Also very useful to do this if you want to comment out certain lines. So if you want to say, okay, I want to run everything, but not this line, so I can just comment it out. Then it's not considered to be code. It's just some text. So this is completely ignored. I can run these lines of code and nothing happens. Just as a side note here. But what I want to show you here now also is logical operators and comparison operators. So we talked about the logical data type. We have true and false values. T is true, F is false, and these can now be combined into statements. So what is a logical operator? A logical operator is something, maybe if you had logic in your university or school, you know what logical operators are, but basically we have things like a logical AND, a logical OR, a logical NOT, and they combine these Boolean values, or this logical values, truth and false, and they combine them into an overall statement, which in the end is also either true or false. For example, true and true with two AND symbols is obviously true. True and false is not false, because the AND operation requires both operators or both variables here, both values, to be true. False and false is also not true. So everything has to be true for the AND operator to result in true. Now we also have the OR operator, which is two pipe symbols. So it's this one here, two pipe symbols, and OR is false if we have false or false, but it's true if we have at least one true. So the OR operator just requires a single true statement, then the entire statement is true. So you can think about this if this is too abstract now. We can say there is a statement, it is raining right now and I am happy, for example. Now, this statement is only true if both statements are true. So it's raining right now and I'm happy. If one of the two statements is not true, the overall statement is false. But if I say or, if I say it is raining right now or I am happy, it's true when either one is true. So if it's raining right now and I'm unhappy, it's a true statement. If I'm happy and it's not raining right now, it's also a true statement. And if both is true, it's also a true statement. So that's the OR operator, the two pipe symbols. Then theoretically, you could also have an exclusive OR. We're not going to cover this one now. This would be an either or, so if both is true, it's false. But then we also have not, so a negation. If you have, for example, true, and you add an exclamation mark in front of it, it's not true, which is false. Now, why are we learning about this? Why would I ever combine logicals? You don't do it explicitly, so you don't go ahead and do some true and false or you don't do true and false or true or something. You don't do that. You usually get these logical values as the result of other operations. For example, comparison operations. Comparison operations are just statements that can either be true or false. For example, the statement 2 is less than 5 is a true statement. The statement 2 is greater than 5 is a wrong statement, so a false statement. 2 is equal to 5 is also a false statement. So we use two equation signs or symbols to say this is equal to, not as an assignment, but as a check. Is 2 equal to 5 is specified like this. This can be either true or false. Then we also have not equal to, so exclamation mark equals, that is true. And then we also have stuff like greater than or equal, and we have stuff like less than or equal. Now, again, why would we do something like this? We don't do it like this. We usually do this with input, with something that we read from a file, with something that the user inputs. So if we have a variable a, and let's say this variable a is set to something that is read from a file. So you read some file, and then there is a value, and you want to see if that value is less than 5. So you can say a is less than 5, in this case, false. But you can combine these things into different statements. So for example, a is less than 5, or a modulo 2 is equal to 0. So it would mean that a is even. Now this is of course also false because a is 11, so it's not less than 5, it's also not even. But I can say, okay, then at least maybe a is greater than 7 or something, and then this overall statement would be true. So it is quite abstract yet because we don't have any practical examples here, but these are the basics. You need to know that these things exist, and then we can use them in meaningful scenarios. So if we load a data set and we want to filter all the values that are above 7, for example, for a certain feature, for a certain column, these are the things that we use here. So we have these comparison operators. They return logical values, so Boolean values, trues or false, values, and then we can combine them with logical operators, with and, with or, and with negation, to turn this into an overall statement which is true or false. And then of course this can be used to make decisions. We're not there yet. We're going to cover this in a future video, but we can do certain things like execute this part of the code only if a certain condition is true. If it's wrong, do something else. We can do stuff like this. We're going to talk about this later on in the series. But these are now the basics of the R programming language. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.